there, my name is Dr. Marissa May, and this week we're going to be taking a look at variables and expressions and all the foundations that we need for our college algebra class. So I'm super excited that you're here with us. The beauty of this video is that you're going to be able to pause, take some really good notes as you're going along. I'll be sure to link the PowerPoint in the description so that you can take a look at those if you would like to. But let's dive right in. So we're going to start with this question. What are like terms? Well, like terms are simply terms that contain the same variables, those are the letters, and the same variables have the same powers. So maybe our expression is going to have A's and B's in it. Maybe it's going to have X's and Y's. But we're going to be looking for the exact same combination. Let's take a look here at some examples. For instance, 2ab to the second and negative 4ab to the second are like terms. You see they have the same variables, a and b, and the b has an exponent of 2. So we know that these are like terms. Let me give you an example of two that are not like terms though. So 2ab to the second and negative 4a to the second b. See, now while these have the same letters, the same variables, those variables don't have the same exponents. So those two are not like terms. You're going to be looking for with a very critical eye here so you can pinpoint the ones that are like terms versus those that are not. So why do we want to be able to do that? Well, because we want to look at something called collecting like terms. That means we want to get the terms together that are like terms, and we want to combine them. So let's look at these 4 terms that we have in the expression. Notice that the 4xy and the 7xy, those are like terms. They both have an x and a y. Now what we can do with that is add those numbers in front. So 4 plus 7 gives me 11xy. Be very careful here. You'll notice that I did not change any exponents. I didn't make that 11x to the second, y to the second. I have a lot of students who want to do that. Don't fall into that rabbit hole there. Let's see. Negative 4xz doesn't have a like term to go with. So it just becomes part of the solution. I didn't have one to combine it with, so I have to include it as part of the solution. And the same is true with negative 11yz. There's nothing to combine it with, so it becomes part of my answer. And this is what we would say is the answer when we ask you to collect like terms. We combine the terms that are alike, same variable, same exponents, and we don't combine those that are not alike. We just include them as part of the answer. Next, let's take a look at solving an equation. Now, friends, let me let you in on a little secret here. I believe you probably could look at this and just kind of guess and check and figure out what x would be here. However, when our equations get more difficult, figuring it out gets a little bit more difficult too. So I'm going to lay some groundwork with some strategies that are going to work no matter how difficult the equation gets. We're going to be able to come back to these strategies. So bear with me on these easy equations. I'm going to build technique, okay? So the first thing we do is we ask ourselves, what's happening to the variable? What's happening to x here? You're right, it's adding 5 to it. So we need to do the opposite of adding 5. Now the opposite of adding 5 is to subtract 5. I want you to take a look at where I subtract 5. I subtract 5 on the left side of the equation, and I also subtract 5 on the right side of the equation. Think of that equal sign as being the dividing line, okay? So I got to do it on both sides. You've probably heard the phrase that says, whatever you do to one side of the equation, you got to do to the other side. And it's true. Now let's see what happens. When we do that, plus 5 minus 5 cancels each other out. We get that x equals negative 7. And again, that's probably the answer you just kind of figured out in your head. But remember, we're building technique that's going to work no matter how difficult our equations get. So let's get to those little bit more difficult equations. Okay? 2/5 x equals negative 13. Ew. How many of you are like, fractions are not my friends? I hear it a lot from students, and yet I want to debunk it a little bit. I want to make it so that it's a little bit more normal and you know how to handle it, okay? So fractions, we do a little different. I want you to notice I'm still going to ask myself that question. What is happening to the variable? What's happening to x? It is being multiplied by 2/5. So in order to remove the fraction, we flip it and we multiply it. We flip it and we multiply. So instead of 2/5, you're going to flip that. You're going to put the 5 on the top, the 2 on the bottom, and you're going to multiply both sides by that. So here's what it looks like. I'm going to multiply by 5/2. Notice that I did it to both sides of the equation, though. So let's recap. I flip it, and then I multiply on both sides of the equation. So what does that look like then? To type this in your calculator, because let's be real, I want you to have your calculator with you. You type in -13 times 5, and then you divide by 2. So type that in your calculator, -13 times 5, divide by 2. Newsflash, it's not going to come out evenly, okay? That's all right. I get x equals -37.5. Are we okay with those kinds of answers? Yeah, it's okay when it doesn't come out nice. Now, I know usually in a math class, when it didn't come out nice, you're like, oh, I did something wrong. We don't consider -37.5 to be what some might say like an ugly answer. All right, let's move on to a two-step equation. You may be saying, Dr. May, well, what is a two-step equation? A two-step equation is where you see two things happening to the variable. So again, we go back to that original question. What is happening to the x here? Two things. It's being multiplied by 7. It's being subtracted by 2. So we have two things to undo, okay? I want to remind you that we're always going to take care of the plus or minus first. So we're going to take care of this -2 first by doing the opposite of -2. Now, the opposite of subtracting 2 is to divide 2. So we're going to add, I said that wrong today. We're going to add 2 to both sides because the opposite of subtracting 2 is to add 2. Notice that I did it to both sides of my equations. That's important. So I'm going to be left with 7x equals 24.5. 7x equals 24.5. Now we're ready to take care of the multiplying by 7 part. And the opposite of multiplying by 7 is, you guessed it, that's right, it's dividing by 7. So we're going to divide by 7 on both sides of the equation. And we're going to go to our calculator, type in our 24.5 divided by 7, and that's going to give me that x is 3.5. Again, two-step equation because we had two things happening to the variable. We had to undo both of them. I want you to remember we undo add and subtract first, then we undo multiply or divide. How are you doing? We've covered one-step equations, now two-step equations. I hope you are seeing the technique we are building so that no matter how difficult our equations get, we still know how to work through them to solve. All right, let's take a look at this one. 7 parentheses t minus 5, close parentheses, equals 42. This one is a little bit tricky, but I want you to see the similarities because I'm going to bring us back to that two-step equation idea and then bring us back to the one-step equation. See, this really is going to be a two-step equation, but I have to do a simplify step first. So previously in our course, we talked about the distributive property. So anytime we see that number in front of a parentheses or an expression in front of a parentheses, we know that means to multiply. So we're going to distribute that 7 to the t. So 7 times t would give us 7t. And then we distribute the 7 times the 5, and that gives us 35. So that first step is a simplify step. It is using the distributive property. Now look at our equation. We've got two things happening to that variable t. We're back to a two-step equation. So now we can ask ourselves that question. What's happening to the variable? Being multiplied by 7, being subtracted by 35. So we're going to do the opposite. Remember, we take care of add or subtract first. So we're going to add 35 to both sides. Notice I did it to both sides of the equation. Remember that old phrase, whatever you do to one side of the equation, got to do the same to the other. So when I add 35, I'm left with 7t equals 77. And now we get rid of the multiplying by 7 by doing the opposite of multiplying by 7, which is to divide by 7. So we divide by 7 on both sides, and we get that t is 11 here. So recap, this really was a two-step equation. The only difference is we had to start with a simplify step, a distribute step, before then we could ask ourselves that, what's happening to the variable? We got to do the opposite. I hope you're catching that it's the same process though. That's really, really what we're after. All right, friends, let's take a look at this equation. 3a plus 2 minus 5a equals negative 14. You'll remember in our last problem, we did a simplify step at the beginning. It was using the distributive property. We're going to use a simplify step here. However, it is not the distributive property. We are going to combine those like terms. Did you see them? Did you see the two terms that have the same variable? Yes, I'm so glad. The 3a and the negative 5a are like terms. We talked about it at the very beginning of our video. They're like terms. So when we add 3a's and negative 5a's, we get negative 2a's here. So my equation becomes negative 2a plus 2 equals negative 14. See, now I've come to a two-step equation again after I did a simplify step first. So now let's ask ourselves, what's happening to the variable? The variable's being multiplied by negative 2 and being added by 2. So which one do we take care of first? You're right. Yes. I'm going to take care of that adding 2 part by doing the opposite of adding 2, which is to subtract 2. So we're going to subtract 2 from both sides. And that leaves me with negative 2a equals negative 16. By the way, if the negative 14 minus 2, if that kind of throws you a little bit, use your calculator. If you need a free online calculator, check out the description below. I have a link to the free Desmos graphing calculator. You may want to bookmark it. It definitely will probably help you with some of these equations and just doing your calculations. Did I mention it's free? I always love free things. All right, friends, let's finish up this equation here by taking care of the multiplying by negative 2 we see on the A here. So we do the opposite of multiplying by negative 2, which is to divide by negative 2. And that leaves me with A equals 8. I hope you're seeing the connection by looking at what's happening in the equation and doing the opposite of that as your solving technique, so that you then get the variable all by itself. That's what we're doing, is trying to get that A by itself equals everything else on the other side of the equation. And we're using the opposites to help us do that. So good work so far. We've made a lot of progress. We've gone through one-step equations, two-step equations. We've covered 2 different types of simplifying steps before we started into those two-step equations. And now let's take a look at a variable on both sides. Ooh, this one looks intimidating. I don't know about you. We're going to go kind of slow because I want to make sure we don't make any mistakes. It's always a good thing to go slow. Write out all your steps. When I skip steps, that's when I take the chance that I might make a mistake. So I want to avoid that. I also see the numbers in front of the parentheses on both sides. So I want to make sure that I definitely do some simplifying at the beginning. I'm going to distribute there. I'm going to distribute the 2 on the left side. I'm going to distribute the 3 on the right side. So let's take care of that. Remember, when you distribute, you multiply. So 2 times x gives me 2x, and 2 times 3 gives me 6. Then we look on the right side. 3 times 2x gives me 6x, and 3 times 1 gives me minus 3. And don't forget my minus 10 there on the far right side of the equation. I don't want to lose track of that, definitely. So did a simplify step first, which was to distribute. And then notice on the right side, I had minus 3 minus 10. So I went ahead and combined those to give me negative 13. Now, friends, you see I have x's on both sides of the equation. I have 2x on one side. I have 6x on the other side. I have to get those all on one side first before I start doing the opposite thing, okay? I like to go ahead and get my x's all on one side. So I'm going to take that 2x and I'm going to subtract it from both sides. I want you to watch where I line it up though. Notice that I line the 2x when I subtract it underneath the 2x and I line it underneath the 6x. I'm doing that because they are like terms. So let's take a look at what I get when I subtract those. I have 6x left on the left side equals, now watch, 6x minus 2x gives me 4x, then minus 13. Now look at what we have. We have a two-step equation. Remember, we have two things happening to the x. It's being multiplied by 4, it's being subtracted by 13, and now we have to take care of both of those. So we're going to do the opposite of subtracting 13, which is to add 13 to both sides. That leaves me with 19 equals 4x. Now we take care of the multiplying by 4x by doing the opposite, which is to divide by 4x. And we don't get a nice answer, but that's okay. We get x equals 4.75. Let's recap what we did in this problem because it has a lot of steps. We did a simplify step first, which was to distribute. Then we combined like terms with that minus 13 minus 10. Then we got all of the x's on one side of the equation. We did that by subtracting that 2x. If you remember, we lined it up underneath the x terms. And that gave me the two-step equation that then I could start undoing the operations just like we did in the previous problems. So we're building strategy, we're building technique with every example that we do here, but I want you to see that a lot of the techniques are the same. We're getting it down to that two-step equation. Then we are doing the opposite in order to solve. Let's turn our attention then to solving an inequality. These are, you'll notice instead of that equal sign, now we have a less than or equal to, but here's the inside scoop on these. We solve them the same way we do an equation, with one slight difference, which we'll talk about. So let's take a look. What's happening to the variable? It's being multiplied by 4, being added by 23. So we're going to do the opposite of adding 23 first. So we're going to subtract 23 from both sides. Notice that's going to leave me with 4x is less than or equal to negative 12. Now we have to get rid of the multiplying by 4. And so we're going to do the opposite, which is going to be dividing by 4 on both sides. And that leaves me with x is less than or equal to negative 3. All right, let's take a look then at this inequality. We're going to solve it, and then we're also going to graph. So we have x divided by negative 2 is greater than or equal to negative 2. We have x divided by negative 2 is greater than or equal to positive 2. So what's happening to the variable? It's being divided by negative 2. So we're going to do the opposite of dividing by negative 2, which is to multiply. So I'm going to multiply both sides by negative 2. Now here's that one difference in how solving inequalities is different than solving equations. Because we multiplied by a negative number on both sides of the equation, we have to flip the inequality. So instead of a greater than or equal to, now it becomes a less than or equal to. So that's our one cardinal rule of solving inequalities. If we multiply or divide by a negative number on both sides of the inequality, you must flip the inequality. So x is now less than or equal to negative 4. Now let's talk about how we would graph that on a number line. I want you to notice that this is less than or equal to. So the equal to matters because the equal to tells us that we should put a closed circle or a filled in circle at negative 4. Well, something like that. And then we want to go less than negative 4, or if you'll notice that arrow pointing to the left, we would then shade to the left of negative 4. And this would be the graph. This would be all of the numbers. X is less than or equal to negative 4. Remember, if you see the equal to underneath your inequality, That's a closed circle at that point. So I hope this helps you with your concepts this week as you're solving equations and inequalities. Be sure to look for that variable and ask yourself what's happening to the variable, and then you'll know to do the opposite in order to get the variable all by itself. Be sure to leave me a comment below if there's anything you would like me to discuss further. I would love to help, and I hope you have a great week. Bye for now.